What we have here is an immersion cooling situation where we have a Cisco C220 UCS server, and it's operating at 100% utilization of those CPUs. Now, one of the interesting things we have here, if I could show this screen, is we have 100% utilization of those CPUs, and you can look at these operating temperatures of here, well below 80 C. Typically, you see 80 to 90 C.
Hey everyone, it's David Bombal coming to you from Cisco Live with a very special guest. Denise, welcome.
Thanks. Wonderful to be here.
Denise, I got a surprise for you. So if you can turn that page over, or that paper over, this is an article from the BBC talking about how the UK wants to become a leader in AI, but, which seems really surprising, they may not have enough water in the UK to power the AI data centers. I hear there's a real problem. AI is taking off. Data centers are getting built like mad.
Yep.
But power, electricity, if you like, water are problems. How are we going to solve this? Or has Cisco got a solution? Or, where are we going?
Well, I feel like this is a quiz, first of all. And second of all, we're going to nail it because those are two things that are near and dear. We've been at this now with Engineering Sustainability Office as sort of a formal function for about 3 years. And the premise has always been to integrate systems so that we can unlock more power efficiency, energy efficiency. The water shortage is something a little bit newer because depending on the technology that's in to cool data centers, and what AI has simply done is put a spotlight on the issues that we've known for so long. And so we have been at this. We've been at this for a while, and I think there are very few companies who are well positioned to bring all of these different systems together, and then create an ecosystem that actually is efficient and sustainable. And now there's pressure. Before, without the urgency or pressure, it's hard to make the case, right, for anything to change or move. How often are you completely redesigning a data center? And yet, what do they say? They say necessity is the mother of all invention.
Yeah.
So here we are.
Yeah, it seems, I just reading some articles from the IDC, it says here that Europe needs to spend like $1 trillion to power AI. So, it seems like AI is going like this.
Yep.
Data center builds are going like this.
Yep.
We haven't got the power, we haven't got the water. So how is sustainability helping this? Is it making the devices more efficient? Are you doing some clever stuff, or what's happening?
So let me walk you through, where to start, what customers are facing with today, and then I'll tell you a peek in the future of what's coming in art of possible. Okay, so first and foremost, like the principles of networking, you can't fix what you can't see. So everything is about visibility. So we have spent the last, handful of years specifically unlocking standardization in energy management. We've actually simplified it down to 5 key metrics for energy measurement. And we've built that into the telemetry across our entire end-to-end portfolio. At the moment, we have 13 controllers, right? Cisco is always on this mission to simplify. So as we build towards North Star, I'm sure that will get, the number will go down, not up.
Yeah.
But at the moment, we are in the process of rolling out. We have 4 of the 13 on the process of rolling out the rest. And those 5 key energy metrics: how much energy are you using? What's the cost of that energy? What's the greenhouse gas footprint of that energy? There's something called carbon intensity, and there's something called energy mix. These 5 metrics are now available through Cisco's telemetry built into the dashboards, part of existing licenses, right? So we're not charging for visibility. All customers have this. The only 2 parties that have access to that information is Cisco and the customer. So all the services that are coming, and there are many services, right, are starting to build practices around, let us help you capture this information in an intelligent way. So once you have visibility, you can start to do insights and analytics off of that. And we had a tiny little acquisition called Splunk not too long ago.
Just a small one.
Just a small one, where data is king and queen, right? So once you have those insights and those analytics, just imagine what you can do with automation. So that's the foundation. Set the foundation with energy management. Well, now that you can measure energy, you can peek inside of data centers and say, whoa, why are we spending half of the energy bill on cooling? Look at the water usage. So to go back to this, right, shortage of water. So now we have those insights. So then we think about, okay, well, what can you do with the existing equipment? Like you would in maybe a home or a building, you're turning off light switches everywhere you possibly can when they're not in use. Well, that's great. That's incrementally going to help maybe a couple points here and there. That's not going to get you leapfrog innovation to get ready for AI.
Yeah.
And so what you need is new technology, right? New innovation and new designs that completely break the mold and completely break those silos. Have you heard of a new technology in electricity, a new breakthrough called Class 4 fault managed power?
I haven't. You got to tell us about it.
So I carry these cables around, and I would say 9 times out of 10, someone's half expecting me to pull out, chapstick or lipstick from this little bag. But, 20, 25 years ago, when we pulled out power over Ethernet and said, this is going to replace all the telephone lines,
Yeah.
I'm sure there were a lot of people that were laughing.
I remember those days.
Right?
I'm old enough to remember
okay.
that. Yep.
So imagine putting voice and power over the same line on this night, power over Ethernet cable, and then saying we're going to power all the APs and cameras with this.
Yep.
There were a lot of people who were very skeptical. Fast forward, we now have entire ecosystems in the built environment that are being powered with PoE. The problem with PoE is it tops out at 90 watts, about 100 watts. From a physics standpoint, Class 4, power over Ethernet, you just can't go any farther. About 8 years ago, one of the heads of engineering went back to our Cisco fellows and some of that community and said, hey, what comes after this? And a Cisco fellow by the name of Joel Gorgon started working on what comes next. As of 2023, in the National Electrical Code, there is a new class of power for the first time in 45 years.
Oh, wow.
Okay. So back when, definitely not old enough for the current wars, but, back when Tesla and Edison were fighting over AC and DC power, who was a clear winner, where there isn't quite a clear winner.
Yeah.
We know DC is far more efficient, but are you playing with, high voltage DC power at home? I hope not. Right?
Yep.
So class 4 fault managed power is up to 450 volt DC, and it is safe to touch, just like power over Ethernet. It has class 2 cabling practices, so it has the same cabling practices. So if you were allowed to cable power PoE, you would be able to power fault managed power.
Oh, wow. So sorry to interrupt you, a network engineer could do the cabling rather than an electrician.
Correct. Okay. Correct. And so power over Ethernet for, that final mile, well, now we have something for the backbone. And to tie that back to data centers, why is that so important? Imagine being able to remove copper bus. Imagine being able to remove all of that cabling, that heavy, thick cabling you see, in the tops of racks of data centers. Imagine bringing that down and powering it with a new type of cable that can do direct. So all of the conversions that you go AC to DC, think about how many times you're going through PSUs to get useful power inside of a box. Yeah. It's at least 3 or 4 times. So just that energy conversion savings is tremendous. So we start adding up between new technologies that are starting to come a little bit more accessible to mass market, like immersion cooling, direct to chip as a transition. All of these things are starting to break the molds. Do you have any idea today what the average density of a data center rack is?
You got to tell us.
So today, in most customers I talk to, and the data supports this, it's around 10 kilowatts a rack. When you start looking at inference training for AI, or you start even doing training models for AI, those numbers are going well over 100 kilowatts a rack, all the way into 200 plus. We're even seeing some for the hyperscalers that are in the 300s.
Wow.
The density per rack, we don't have a space problem, right? We have a power and a cooling problem.
Yeah.
Again, with new technology, well, how are you going to power that rack? How are you going to make sure that rack doesn't burn up? Both from a safety standpoint for the electricity, but also from a cooling perspective. The chips are running so hot, physics will necessitate that chips can no longer be air cooled. So whether you're doing direct to chip or you're fully immersing a tank, and for the first time in our Cisco Live history here in Amsterdam, we have 2 immersion tanks on the floor. So you can physically seeing is believing, what it looks like, to dunk a server, to have fully immersible optics. It's pretty wild to see in a lab what it takes to configure these boxes. It's not hard. It's not that much, actually. We're not manufacturing brand new things only for immersion. At least not today. Maybe in the future we will. But you're removing fans. You're removing heat sinks. You're recovering just a couple of things, and then with the right sticky hands, because dunking it in mineral oil can be a little slippery. You just drop it right in the tank. And so when you think about powering a data center and then cooling a data center, adding new technologies on top of that ability to see what you're doing and measure from that baseline of energy management is how we start to bring all these systems together.
So, immersion, you're taking the servers, the switches, everything, and just dunking them directly in this liquid, right?
That is the future.
But it's not water, right? Because I think a lot of people watching will know like water-cooled PCs and stuff like that. How's this different?
Yeah, so for all the gamers out there, you're not afraid of putting some liquid near your equipment, but no, this is not it. We use mineral oil. So it has the viscous of almost like a baby oil, and we can show you what that looks like. That's what we're using in the immersion tanks. Interestingly enough, actually, the mean time failure rate goes way up because you're not introducing dust and particles from all the fans. From an air perspective, that's quite interesting. There's no condensation or evaporation, so that's another plus for the maintenance of these things. They're not quite as mass market today as one would think. But what's actually fascinating is I've seen customers start to bring in these tanks bit by bit. So you can use a row and start transitioning that to immersion. You can use another row and start doing, hotspot addressing with rear door heat exchangers and CDUs or units at the end of crack units at the end of a row. And so you can have a mixed environment data center and start testing these things. And provided you have the right baseline, well, now you're in business, right? Now you can choose the architectures that are more sustainable, that aren't going to be as much of a drag on your resources. So to your point about, the water shortages and the concerns about data center rebuilds in the UK, well, imagine if you no longer are needing that water, air chillers on the top, and having all that condensation.
So there's no fans, right? So you said you take the fans out of the service because it's in the liquid. So does the liquid get cooled by it somehow to keep the devices cool?
Well, if you think about how much water will boil, there's a boiling point for water. Mineral oil, that boiling point is so much higher. So it's liquid to air. So the heat that's coming off of that mineral oil is not anything close to what you would have with like PEG water or other solutions that are water based. But it's fascinating the number of PhD chemists that I've seen in some of these liquid lab R&D centers. It's fascinating to watch all of these multidisciplines come together to solve these problems.
And you're solving the problem of noise, right? Because data centers are notoriously noisy.
That's right. So today you walk into data centers, they are noisy, they are cold or hot, depending on what aisle you might be in. They're quite dangerous because you see all of these signage that say danger, high voltage, don't touch. So imagine if all that goes away, right? With fault managed power, it's not dangerous anymore. Without the fans, it's not noisy. And with immersion or direct to chip or some form of liquid or immersion cooling, now it's not cold because you won't need to run the HVAC systems, to the hilt all the time.
Denise, I see we've moved locations. We're in the sustainability zone, I believe, and you've got some cool technology to show us.
Absolutely. We often say seeing is believing. The technology in this sustainability zone brings it to life and shows how customers are using this today to make it real. We've got 15 different demos across, and we're really excited to show you a couple of them. Let me introduce my good friend Jeff here. Jeff has been around the world with us in this Pico tank, and we're going to show you, we were talking about earlier, the two different types of liquid cooling. We're going to show you immersion,
right?
Simply because it's a little bit less known. And again, when you see it, it just blows your mind on how energy efficiency can look and feel. So, Jeff, can you walk us through what's behind us here?
Thank you, Denise. What we have here is an immersion cooling situation where we have a Cisco C220 UCS server, and it's operating at 100% utilization of those CPUs. Now, one of the interesting things we have here, if I could show this screen, is we have 100% utilization of those CPUs, and you can look at these operating temperatures of here, well below 80 C. Typically, you see 80 to 90 C. Would be an operating temperature. That means you're going to get equipment reliability, better reliability, and better performance of your system as it operates. As you take a look at what we have here, one of the first things you'll notice is that we have no fans. We deactivate the fans right off the bat. You save 11% of the energy of this system by having that. This unit standalone, we're providing liquid to air cooling.
And let's talk about the fluid, because I think a lot of times people think it's water inside there. What are we actually looking at for the fluid?
Yeah, water is conductive. That's the problem there. So what we have is Shell S3X fluid. It's a synthetic oil that is optimized for heat transfer coming from Shell.
Right. And again, going back to the energy, typically with air-cooled, these units would be running 80 to 90 C.
That's correct.
I'm looking at the numbers here. they're well below 80, mostly like actually below 7, like around 70 and below.
Yeah, you'll see 66 to 72, which is extremely low operating temperatures, which means the equipment's going to last longer and it's going to perform better day to day.
This whole concept of, asset longevity, when you're removing fans and removing the concept of dust and air and sand getting in those systems is also pretty incredible.
That's right. You should see in a white space, clean environment, an edge. This would be an example of an edge application. But when you're in the fluid, you're protecting the equipment from all the contaminants.
So, David, he said edge, and I could get very excited about edge computing and what this opens up, but that might be something for a different day.
You mentioned edge. What is that?
So edge computing, meaning you're not in a huge data center. You can do more of the compute closer and closer to the endpoints and where the users are.
Yeah, because I was going to ask you, sorry, we were talking about data centers mainly.
Yes.
Is this technology only for data centers, or is it going to be like for enterprises, other businesses?
So this technology can be anywhere, right? And
every industry, we can be in a desert, we can be in a jungle, we can be in a wiring closet, we can be in the white space, and for every industry.
On a cruise ship.
Oh, wow.
Hospitals, like, again, art of possible, moving this anywhere and away from data centers and starting to distribute not only the power, but the compute gets super interesting. And from a campus environment, we're starting to see more and more bleeding together between data center campus.
Yeah.
With AI and where you need the compute, I'm starting to see more pendulum swing back for on-prem data centers, so to speak. We were in the lab. I think we're allowed to talk about this. We were in the lab and playing around. We actually took a catalyst switch, reconfigured it. This gentleman over here did it himself in less than an hour. And again, removing the fans and removing the heat sinks, you can do the same thing and have a server, a switch, and the only industry's completely immersible optics in one tank.
Wow. I mean, I love that because that solves this problem that I kind of highlighted. Because if we use the current technology, I mean, they're talking about building 9 nuclear reactors or something in the UK.
That's right.
And Microsoft brought a mothballed nuclear power station online, I believe, just to try and power these things.
Absolutely. Well, and this is the other thing to consider. Most of renewable energy is DC native today, 380 volt DC. So with fault managed power, we are already tapping into 380 volt DC ecosystems that exist. With PoE, when it first came out, the ecosystems didn't quite exist. One of the things that we're also doing is we have this engineering alliances kind of program, so to speak, where we're leveraging existing things that we have at Cisco, but we're doing engineering validation on vendors that are coming into the ecosystem so we can provide our customers with a full solution. So imagine coming to Cisco and say, hey, I want to retrofit a building. Right? I want to make it as smart and energy efficient as possible. Well, instead of that customer needing to figure out, well, what lights should I use? What blinds should I use? How do I get solar in there? Imagine being able to come and say, hey, I need the network to work and I'd like the network to automate all of these different things. Today, a normal building has over 30 different building management systems. Imagine having that number down to less than 5. That convergence of IT and OT is absolutely starting to happen. And so PoE enabled everything from signage, monitors, blinds, lights, furniture and desks that are energized. All of these things can be completely DC all the way, and renewable energy is DC native. So imagine being able to do that full DC microgrid all the way. Again, fault managed power in the backbone, and then PoE for that last mile. These are things that exist today. Have we fully connected every last ecosystem? Is it available to mass market? No, not yet. But that's where that art of possible is here today, what we're doing in labs, how we're validating this so that we can offer these things, at speed and scale eventually.
I'm a bit slow, right? So we've got PoE, Ethernet cables, and then we've got traditional power. So what's this new technology called again?
It's called Class 4 Fault Managed Power, FMP.
Is that going to replace the power cables and the PoE cables, or is that just
the power cables?
Just the power cable. So you still have your Ethernet cable, and then you have a replacement power cable.
Yep. So anything that uses up to 100 watts, PoE is going to be your go-to. So APs, cameras, sensors, no problem. Phones, you'll still use a PoE cable. Anything that requires much higher voltage, say over 300 watts, this is where fault managed power will start to replace power supplies. Now, what's exciting about today's show and on the floor is one of the partners that we've recently brought into the Engineering Alliance program is Panduit. right? And Panduit is a known entity, a known name. And so one of the first things we're doing, and we can show you this in the demo, is up to 56 volt DC is available today. It's powering our switch, and our switch is powering all of the endpoints in the smart building demo, right? So that is available at mass scale today. What's next is 380 volt DC fault managed power.
FMP, is that something new or has this been around for a while?
Well, I mentioned it was listed in the National Electrical Code in 2023.
Yep.
Right. So that is when it went, I would say, kind of more fully public. In terms of, Cisco and when Cisco is going to announce it on our own personal roadmap, we're not quite there yet. We're hoping that it's soon, but that's why we're partnering with broader ecosystems. There's something called an FMP Alliance, where Cisco has a president's seat. We have the leading number of patents in fault managed power with data and cable on the same line. And so with this ecosystem, it's not a one-person game, right? Energy is everyone. And that's why I would really encourage, this is about everyone having a seat at the table eventually to standardize this, because that's when we win. If somebody said, I can offer you a better, faster, safer way to do power, why would any one company keep that to themselves,
exactly.
right? It's like the seatbelt.
Yeah.
Everybody needs it. So that's really the goal of the FMP Alliance, is to bring education and awareness, but it is new. And I'd like to believe that it's revolutionary. And that's what FMP Alliance is all about, is bringing those companies who are on the forefront of pioneering and evangelizing and bringing that education and awareness. But it's going to take a lot of time. It's going to take all of us. And it's great. This platform is awesome, because for those who are just deciding, what path to take and what interest areas are really going to take off, energy and power is a fascinating space, and there is a global world shortage of skilled labor in the space.
Denise, you were telling me, I believe that buildings consume a huge amount of electricity in today's world.
Yeah, depending on what study, it's 30 to 40% of the world's electricity goes to buildings. And inside of buildings, there are over 30 different building management systems that often have to operate all these various networks. But Liz is here to tell us how we can automate that and make it a little simpler.
Thank you very much. First of all, as Denise said, one of the biggest problems we have in buildings is the sheer quantity of separate networks, duplication, and the inability for things to talk to each other. But with a modern Cisco network that has proper security on, we can combine all those networks together, which means they can start to work together. So the first thing we can look at is the power distribution as well. So on this stand here, we've got a Cisco switch here. This is providing 90 watts per port, which means we're able to power pretty much everything you see here, such as monitors, up and down desks, lighting. So we can now get to the point where most things within the main office environment, we can power from our switch. And Andrew will talk to you a little bit about what we do with the rest of it. But before we do that, one of the other advantages we've got here is we've now got a significant quantity of data. And data by itself is not much use, but when you start to actually get some analytics tools on that data, you can really understand how you're using energy, when you're using energy, when you shouldn't be using energy. And back to the building point, how do I actually need all this building space in the first place?
Liz, as I understand it, some of the studies that we've seen from some of these earlier builds are saving upwards of what percentage can we see from a monthly savings?
Just from, lighting and that kind of thing, on its own, probably about 35%. It does depend where you are in the building and the type of infrastructure you've got already. But yes, it can be that high.
Thank you. And Andrew's got the cables that I often carry around in my bag. Andrew, can you talk to us a little bit about what you're holding?
Sure. So I'm holding in my hand two cables. This one is the PoE category cable, right? This carries about 90 watt, 1 gigabit of data. This, on the other hand, is a FMP cable. You can see it's twisted pair. There's 8 pairs in here. Each pair carries about 600 watt. So in my hand, this is a 5 kilowatt cable.
And tell us about the distance, the efficiency, and the safety of that cable.
PoE, we actually, Cisco started with PoE, right? This is, again, 100 watt, 100 meters, right? Back, I think, 2017, we started thinking about what goes beyond PoE, because 100 watt, that's the end of this envelope. So we have been working with, on the United States side, the NEC, National Electrical Code, to introduce a new class of power, and this can do up to 450 volt, 2 kilometers, unlimited wattage.
Unlimited wattage. Did you hear that, David?
Wow.
And this, in terms of skill sets requirement, cabling, it's all low voltage requirements. So You actually don't have to have really a lot of training. Like I think in US, it's about 3,000 hours of training to actually get certified as an electrician. You actually this is normal technology. Labor force can actually deploy this.
So, fun fact and shameless plug, we just produced our very first Cisco FMP white paper. And we will share that available to the audience because there's a lot to dig into there. This is a quick commercial brief on it. And Alistair, can you tell us where are customers using all this and what are they seeing?
So customers are coming to me on a daily basis and saying, where can I deploy this? And what I'm finding is most are seeing lighting as one of the easy ins. Yeah, and proof of concept is very simple to do. The other thing is, as Liz was saying about gathering data, the office environment, what's actually happening in that office environment, and then making business decisions based on the insights that the infrastructure can give. I think the exciting thing about this from a sustainability point of view is if you moved your lighting to PoE, you only have one cable run rather than two cable runs. And the amount of plastic, precious minerals that you're saving in that sort of deployment can be ignored.
Yeah. So as you can see, this is very much a business-driven decision to save money, save costs, and oh, by the way, you're doing something pretty good for the environment.
Yeah, I mean, it's amazing the amount of money has to be invested to try and solve this problem. Like you said, AI has just put a spotlight on it, it seems.
Yeah, that's
so there's
right.
a lot of opportunities for people who are like young or perhaps not sure what they want to do, right?
Or people doing a career pivot.
Yeah.
Right? Absolutely.
You mentioned direct to chip. What is that?
Yeah. So when you think about liquid cooling inside of a data center, there's really two main types. There's what's called direct to chip, where you'll have a cooling distribution unit sitting either in rack or at the end of a rack, feeding cold or chilled water directly to a cold plate behind the chip on the board. And then there are different types. There's single phase, double phase, there's closed loop, open loop. So there's a lot of different types, but direct to chip means there's chilled water going directly to a chip and then some closed or open loop that's removing the heat from the chip and then expelling the heat somewhere else, whether they're, fans on the chillers off the roof or, out the back of a building. The other type is immersion. And immersion cooling, some will say is or is not liquid, but immersion cooling is different. And in immersion cooling, you're usually using some sort of mineral oil.
So Denise, Cisco have been doing sustainability for a long time. And I believe, I don't know the exact figure, is it 99% or something of Cisco devices are recycled? Is that right?
Yeah. So let me dig in because this is something I feel like we should be singing from the rooftops when we think about Cisco's been working and it's just ingrained in who we are, right? So from a ratings and rankings perspective, there are things like the Climate Disclosure Project, CDP. We just got another year of A rating. There's a number of ratings and rankings out there, EcoVadis, GRI, science-based target initiatives, where Cisco continues and continuously has top marks. Why is that important? It's important because it's reflective of things like our supply chain, our take back, the products that we're putting out and how efficient they are. And so with our supply chain, sometimes we get number one or number two by Gartner each year. And our supply chain leadership has been working at this for decades. Right? We talked about Cisco being 40 years old. Well, direct relationships with every single component supplier doesn't happen overnight, right? It's something they've been hard at work at. And what's amazing about this is it allows us, we have a 100% take back program, which means any customer anywhere in the world, we will take back our product for free. So we pay for the shipping and handling and we'll come pick it up. And then 99.98% of that product can be responsibly recycled, remanufactured, or reused. And we have this incredible demo where we're physically taking apart and showing how modular the build and design is. So circular design principles are built into every one of our new product design. We actually have patents and IP on how we deconstruct and recycle and reuse some of our equipment.
Denise, where are things going? I mean, it's hard to predict the future, but where do you sort of see us heading?
So I think there's a couple of constants, which I think is so exciting about. Now we just need to apply more urgency. Some of the constants are power and energy. We have to figure out better ways. There's so much wasted energy inside of our buildings, inside of our data center, inside of all of our energy systems. That's one. Two, we need to start bringing more and more of these ecosystems together. And when we start doing that, we see more and more optimization happening across the board. And I think that is the critical aspect of bringing together new development at speed and scale into these ecosystems, and validating that from an engineering perspective, and being able to kind of curate which systems need to work together for the most efficiency or for, the best outcome. I think the world needs not just these incremental changes, but big leapfrog changes for what the next kind of big transformation or revolution is going to be to support these new models. And so I think it's that fresh thinking. Don't try to do bit by bit. Let's look at completely new designs and go at it at once.
Denise, dodgy question perhaps. A lot of young people want to save the environment and are very environmentally focused. But unfortunately, a lot of the older generation perhaps aren't. And a lot of business people might say, where's the ROI on this? Is this just about trying to save the environment, or is there a business savings to doing this kind of stuff?
I'm actually really glad you asked that question. And there's two aspects to that. First and foremost, if this was not a business viable opportunity, I would not be talking about it. Not because I don't care about the world, but because I do a lot of give back to my community and save in my off hours work time. I think this is a tremendous business opportunity, and that is further substantiated. There's a ratings and ranking out there called the Global Corporate Knights. They look at the top 100 sustainability companies of the world and do an index. For the past 10 years, those 100 companies have outperformed every major indice in the world. And so as younger people are making their decisions and voting with their feet where they're going to go work and how their purpose and their work drives them, this is where the second part of your question, we need all the generations in the workforce today, and there are 4 key generations that are still in the workforce, and they will be for a couple more years. We need all these generations to work together, because those coming in who just want to save the environment and those leaving who know how those things were built and why they're so energy inefficient, they all need to work together to solve these problems. I've actually had the pleasure of working with people who are maybe in the last handful of years of their work career, saying, before I leave, I want to fix the problem that we all created. And the only way we're going to do that is if they can transition some of that knowledge into the younger generation.
I love that.
Yeah.
Thanks so much, Denise, for sharing. I wish we could have more time.
Yes,
Appreciate
wonderful
it.
to be here. Thanks.